and welcome to another WJEC A level physics question. This was from January 2009, Unit 1, and it was question 2 on the paper, sort of a basic forces and vectors and scalars type question. So, first part of the question, give the essential difference between scalar and vector quantities. Well, what we're looking for here is the fact that vectors have a size or a magnitude and direction. Scalars only have the magnitude. There's not much room to write an answer in here, and they're asking specifically for the difference. So I'm just going to say that vectors have direction and scalars don't. Next, we're given Newton's second law as sigma F equals ma, and we've got to identify and name the vector quantities in this equation. Well, sigma F is one of them. That represents the resultant force. You might be able to get away with just put in F for force, but sigma F is a better answer. M is mass, which is a scalar, so the other vector is A, which is the acceleration. Next, we're asked to give two examples of scalar quantities. We could use mass, but let's use two different ones. So, for example, we could use speed and volume, or distance, or density, and so forth. Next part of the question, we have a car stuck in sand and it's being pulled by two ropes with forces of 450 and 600 newtons as shown on that diagram there. Now, to me, the easiest way of adding vectors is to put them tip to tail, so I've added a little bit to this diagram and redrawn the 450 newton vector with its tail at the tip of the 600 newton vector. The resultant then is from start to finish. The question asks us to find both the size and direction of the resultant of these forces. So what we're going to do here is, to find the size, we're going to use Pythagoras' theorem. And if you're really sharp, you might spot that 450 is 3 lots of 450 is 3 lots of 150. 600 is 4 lots of 150, so therefore this resultant is going to be 5 lots of 150, a 3, 4, 5 triangle. But let's just show the workings that we would do if we wanted to write it out in full. So we've got square root of 450 squared plus 600 squared gives us an answer of 750 newtons. We've also got to find the direction, and I've seen many candidates over the years say that the direction is southwest because it sort of looks southwestish. But for it to be a southwest direction, this angle theta would need to be 45 degrees, and that would mean that the triangle that we've got here would have to be an isosceles triangle, and it's clearly not. So instead we're going to use trigonometry. Tan of theta would be the opposite 450 over the adjacent 600, so theta is tan minus 1 of 450 over 600. So let's put that into the calculator. And we end up with 36.9 degrees, or 37 degrees will be fine. Now note, because I put the angle theta on the diagram up here, then I don't actually need to sort of go any further than just saying that the angle is 37 degrees. In maths, they'd like you to sort of clearly state what that angle is. So you could say it was 37 degrees below west, or you could give it as a 3-digit bearing. But in physics, mark the angle on the diagram and calculate that angle. Last part of the question says that the car remains stationary but the bumper suddenly breaks away. We've got to calculate the initial acceleration of the bumper if its mass is 5 kilograms. So rearranging the equation that we were given above, the acceleration is resultant force over the mass. We've just worked out that the resultant force is 750 newtons and the mass is 5 kilograms. So 750 divided by 5 is going to give us 150. And don't forget the unit in meters per second squared. This was actually a unit question, a unit mark question in the exam, so forgetting the unit would have cost you a mark. Now technically, because acceleration is a vector, then we should also give the direction, which would be the same direction as the resultant force. But the mark scheme for the question wasn't worried about that. So once again, thank you very much for listening. Please remember to like and subscribe, and feel free to add comments below. Goodbye.